Okay, in the next, now we'll discuss basically about the virtual circuits and datagrams. So similar to transport layer connection oriented and connection less services like TCP and UDP we have already discussed, in the network layer there are also connection oriented like the virtual circuit and connection layers like the datagram service are available. A network layer connection service begins with handshaking between source and destination host, and the network layer connection layer service does not have any handshaking requirement. But there are some points to remember. In network layer, these services are host-to-host communication, whereas in transport layer, these services are process-to-process communication. Also, network layer provides only one type of service, either connection service or connection-less service. Computer network that provides only a connection service at the network layer are known as virtual circuit networks, and computer network that provides a connection-less service at the network layer are known as datagram networks. Transport layer connection oriented, basically the connection service have implemented at the edge of the network in the end systems. But in case of network layer, which we are currently discussing, the connection services are implemented basically in the router and in the network layer switches, which are basically the network core components, and as well as it can be implemented in the end systems as well. So there are two types of network architecture, connection oriented and connection less. So these are the virtual circuits, which is connection oriented, and the datagrams network, which is connection less. So these are the two fundamental classes of computer networks, and they use typically very different information in making their forwarding decisions. While internet is a datagram network, many alternative architectures are there like ATM, X.25 and MPLS, and they can use basically these virtual circuit network, and therefore they can use connection oriented services at the networking layer. So the virtual circuit switching examples on the network architecture is when the network architecture is ATM and X.25, and the example is kind of, if you want to bring an analogy, it's kind of a telephone network. Since and in case of datagram forwarding, like it's basically the internet, the packet switching network, the IP networks, and it's kind of there. It is the best of a service. There is no guaranteed quality of service. So the analogy is basically the postal service. So in virtual circuit implementation, we'll briefly discuss its virtual circuit consists of a path from source to destination, and it always involves with a virtual circuits number, one number for each link along the entire route from source to destination, and there are entries in the forwarding table along the router paths. And packet belongs to this virtual circuit. There is basically a virtual circuit number rather than any kind of destination IP address. And virtual circuit number, they change dynamically from time to time, and also they are very specific on each link. There are new virtual circuit number which comes which comes from basically the forwarding table entries. Virtual circuit forwarding table. So let us consider an example over here. So there are two end systems and which are connected with 4 routers, and if you see there is a forwarding table, and for each incoming interface there is an incoming virtual circuit number, and there is also for outgoing interface there is an outgoing virtual circuit number. So let us consider that incoming interface number 1, and the virtual circuit incoming virtual circuit number is basically 12, and if you consider that outgoing interface number is 3 instead of 2, then the virtual circuit number is 22. So virtual circuit routers basically maintain this connection state information, and basically these are the mapping between an interface and a virtual circuit number. So virtual circuits signaling protocol, it is basically used to set up, maintain and tear down the virtual circuit connection, and it is mainly used in the asynchronous transfer mode, frame relay, X.25 and MPLS networking architecture, but not typically nowadays. It is not implemented and used a lot, but let us consider and see how does it work. So first, for a virtual circuit network, there should be some initiation of call from the source side, and then the destination side would accept that incoming call, and once it is accepted, then the call is basically connected, that is the path is already set up, and then the data flow can begin, and the destination can receive the data from the source host. And the destination can basically receives the data. So now let us look into how these forwarding basically works in case of datagram network. So all the destination address basically like the IP address are 32 bits, and considering that 32-bit address can basically find out how many IP address can we support. So I believe there are a billion of IP addresses which can be generated from these 32 bits address, and that's a question for you in the next class. So the question is, given this 32-bit address, how many distinct IP addresses can be generated? It is kind of a pop quiz question, and I will check with all of you whether you could answer this question, and if you have listened to this lecture, definitely you would have some insights. So let us look into this, that is whether we should put this billion of IP address in the routing table and then try to map those output link, or is there a better way to do that? So basically the idea is, instead of putting all those distinct IP addresses, if we can insert the range of address and minimize our effort of putting all the IP addresses in the forwarding table, that would help us to reduce the computational overhead, complexity, and the runtime and searching. So when you search, like you need to search a mapping from the destination address to output link, and if you can reduce the number of entries in a database tables, then definitely that helps to reduce the runtime and to increase basically the response times to find a specific address to output link mapping as fast as possible. So let us look into this datagram forwarding table with this style of forwarding table based on the range based address. The router basically matches a prefix of the packet's destination address with the entries in the table. If there is a match, the router would definitely forward the packet to a link associated with that specific match. This is kind of a rule-based strategy, and let us look into the longest prefix matching. Like sometimes if there are any ambiguity, like if there is any address which might fall into two destination address range, then where the routing and that forwarding table should forward the packet into which interface. So that can be solved basically using these longest prefix matching rule, which we'll discuss in the next couple of slides. Okay, so let us look into this longest prefix matching rule and what is that. So longest prefix matching is basically when looking for forwarding table entry for a given destination address. The concept is use the longest address to match the destination address. So for example, consider that packet's destination address, like at the bottom of these slides, the DA1. So this packets has 21-bit prefix of these address, which matches perfectly with the first entry in the table. So the router forwards the packet to link interface 0, which sounds great, but if a prefix doesn't match any of the first 3 entries, then the router forwards the packet to interface 3. Again, it is possible for a destination address to match more than one entry in the table. For example, the first 24 bits of the address DA2, again at the bottom of the slide, match the second entry in the table, and the first 21 bits of the address match the third entry in the table. So the 24 bits match with the second entry with the link interface 1, and the 21 bits entry matches with the third entry in the table with link interface 2. So when there are multiple matches, how do you solve this ambiguity, like to which link the router should forward the packet? So it is basically based on the longest prefix matching rule. So the router would choose the longest matching, and in this case definitely the answer is it should forward the packet to the link interface 1 because it has the longest prefix matching. So now let us look into these datagram and virtual circuits network and what are the pros and cons in between them. So basically we know the internet, which is basically the packet switch network, is a datagram network. The internet architect, basically the engineers, they chose to make the network layer service model as simple as possible. As we have discussed earlier, the additional functionalities like in-order delivery, reliable data transfer model, the finite state model we discussed in the transport layer, the congestion control mechanism, the flow control mechanism, and DNS name resolution, all those services are implemented at a higher layer, and basically those are implemented in the end systems. Since the resulting internet network layer service model makes these minimal service guarantees, it imposes minimal requirement on the networking layer. So far we have discussed the virtual circuits and the datagram network and what are the advantage and disadvantage of these two architecture. So virtual circuits, there is a need for setting up the connection, whereas in datagram network there is no need for setting up any prior connection. And virtual circuit can provide the guaranteed quality of service, whereas the datagram network is the best effort service. And virtual circuit is kind of like we have discussed the circuit switching network. The telephone network is similar to that concept, whereas the datagram network is basically the packet switch network, and the quality of service is basically the best effort service. So to summarize, the notion of a virtual circuit is similar to circuit switching, which is the telephone network, where you need a call setup and power call state, being maintained at the routers within the network, whereas the virtual circuit network is arguably more complex than a data network.